Following is a video on the general problem solving strategy called recursion. Now recursion itself is a part of a more general strategy called divide and conquer or divide and rule, wherein a larger main problem is divided into smaller sub-problems, and the sub-problems are individually solved. Now that is a general approach, but recursion is also a part of that. Now the reason why I'm making this video is that it is a very, very powerful technique. And I shall illustrate it with a simple example, since all my videos more or less so far almost all of them deal with data compression, how this just this simple technique of recursion can be applied to solve most computing problems, almost all of them. Even everything in computing has a recursive structure or a pattern to it, recursive pattern to it. Now, how to go about solving a problem recursively? The first step is the easiest of all. Assume that the problem has already been solved for the most general case. For the most general case. Okay. Now when a problem is subdivided into smaller problems, the larger problem is called, I'll call them as the main problem, and the smaller problems I shall call the sub-problem. Now, it is possible to divide or decompose the main problem into smaller dissimilar problems. Then it's not direct recursion, in the sense that you use the solution to some other problem which is related to the solution as part of the solution to this problem, in which case it becomes a part of a wider strategy of divide and conquer. But here, you divide the main problem into sub-problems of the same nature or the same sub-problem. So that is recursion here. So here, to solve a problem by recursion, which is more than sufficient for most cases, assume that the problem that you have already solved. This is the easiest step to do. The second step is the interesting one. It contains two parts. First is, okay, now we have the larger problem. First is, assuming that the problem has been generally been solved, assume for all the cases the main problem itself has been solved. That means the sub-problems have also been solved. Okay? Assuming step 1, express the solution to a larger main problem. Construct or build a larger problem. Here, to solve the problem, you're building a slightly larger problem. And express the solution to the larger problem in terms of the solution to its sub-problem, assuming that you have already solved the two or more sub-problems. In this case, okay, express the solution to the larger main problem in terms of its solution to the smaller sub-problem. Assume solution to its smaller sub-problem. This is a general strategy. This is a problem solving strategy as well as a programming strategy. both of them, but ideally you should use it as a problem solving strategy. If you learn a little bit of mathematics, you can use it. This is nothing but inductive. So now what here in the case of our case, then finally the third step is also the simplest. In that, solve the problem for the simplest, smallest case. For the base case. So let us apply this strategy to try to solve the problem of data compression. Now firstly we assume that we wish to compress say some length L dash. Yeah, bits, okay. We need not assume any such value. Let's assume that we wish to compress a bigger number here, okay. Really big number. We assume that we have already solved the problem, first step. This is the easiest. Now we break the problem down into two sub-problems here. Okay. Assume that the problem has already been solved. Now we try to express the solution for the larger problem in terms of the solution for these two problems. A simple strategy perhaps would be divide this into say a few parts, divide this also into a few parts. Take some combination of these two and try to solve it for that. You will immediately see that data compression is always possible. In other words, we know that if we divide up this into fair number of parts, we can always take any combination of those, and there will be quite plenty of such possible combinations, right? If this is divided into say 4 and this is 4, 16 different combination of different parts. To build up a larger number, a significantly much larger number can be built up if we think this way. So that is the sense. Now what we have to do is, when we keep breaking it down, we will finally come to a base case. Solve the problem for the base case. Say maybe a byte, or if this base case is solved, and then you can divide the number of parts you wish to divide it into can reduce as the number size, as the depth of recursion increases, the number of parts you wish to divide the sub problem or the sub information in order to obtain express the solution for the main problem. The decomposition into parts can always decrease, because the size of the problem decreases. You are already cutting it down, assuming you are expressing dividing the problem in the first stage, and then expressing the solution for the larger main problem in terms of the solution of the smaller sub. That's all. Then now what can happen is, recursion is the foundational for all of computing, and computing encloses or encompasses two parts. One is problem solving, the other is programming. This is assuming the conventional software engineering model, where problem solving is the first step. Then comes the implementation using a programming language. But if you are somebody who likes to directly get into the groove and start programming for any problem, nevertheless recursion is a very, very powerful strategy. But the ideal way I would suggest is to work out the solution independently, write down the algorithm or the flowchart or whatever it is, and above all, try to verify it if you can before you dig into it's like before you build a building, try if possible to make some kind of a blueprint or whatever it is, and also if possible, or a small scale model of whatever it is, so or test things out a little bit on a small scale, work it out on pen and paper and see, because most ideas, sometimes when you have an idea, it may not exactly pan out the way you think it is, which will lead to another problem solving methodology. So that is also useful. It may not I would say a failure is not necessarily always a failure, but opportunity for success. Now, so this is the general idea. Now, you should notice that where recursion is always only a special case of the divide and conquer. When you when dissimilar this problem can be broken into, firstly it can also be transformed or in some way related to another frame of reference where you are actually solving some other problem, and solution to that problem actually happens to be the solution to this problem. So that itself is possible. In addition, if some dissimilar problem, it can be broken up into dissimilar problems as well, though recursion only means it is broken up into similar problems, or in some cases, as it is in the case of mutual recursion, you break it into another problem which assumes the solution for this problem, and this problem breaks it down into that problem, and it assumes the solution of that problem, and so on. Finally, you only solve the problem for the base cases of both. Then you have built up a solution in terms of each other to the larger. That is mutual recursion, but that is still recursion only. It is never a case of divide and conquer in general, where the problem may be totally unrelated as well. But recursion is both the foundation as well as the backbone of all of computing. It's all in all. So this strategy is very, very useful for solving all problems.